Hey everybody, this is Brad Dyke reaching out to you. This is going to be the conceptual discussion video, and this one's actually going to be a carryover from a surprising positive response, I think, from me saying out to the world, okay guys, we need a new cluster OS. And it's a cluster OS that truly adaptively takes everything that's connected to a digital platform and can utilize it. And that means USB ports, that means printers, scanners, other USB devices, 3D printers, camera system environment, sensor array platforms, CNCs, or channel arrays, and the world is the limit. That's the key thing here. Anything that is integratable should be treated almost like a normal PC operating system, except this operating system is a universal cluster plug and play environment, right? So I saw a lot of questions out there, and there was some some time ago of an attempt at this, and it kind of fizzled out because of Hyper-V and so on. This isn't Hyper-V. This is way beyond Hyper-V. What this is really talking to is the nature of computing and how you can get it out of the static, stuck place PCs are at, devices are at, towers, racks, servers, you name it. They are limited, right? Because of the fact that when you're working in an environment, individual PCs can do so much more individually because they're interfaced by a series of USB connections, and they have got devices on board, and so on and so on. And my servers downstairs don't have access to any of that. But what if they were all in a common cluster? And the pools that are created by the workstation ID name and the resource. Let's say you have a USB scanner, a typical ADF auto feed scanner. You have a three-dimensional scanner for supporting 3D printing. But the scanner is valuable because it can scan anything, right? So if you broke something, you can put it on the scanner and it can scan it and get you all the details you need to be able to reprint this plastic housing in a plastic 3D based printing setup, and so on and so on. Now, if you take into consideration that some of you nerds out there, like myself, might have other USB integrated devices, including analog converters, which means anything you connect up to those, weather systems, odometer sets, sensor arrays, sky's the limit, because they connect to the converter, which goes to the USB port and is an available resource. So again, every operating system in the house has the same operating system, and they all present themselves as a pool of power. So the only place where this would hurt would be gaming, because this isn't for that. Now, with that, in the future, even appliances, PD devices, may they be wall-mounted or handheld or cell phones or whatever, could technically be added as well, which would add a level of communication sophistication, as well as add avenues of pathways for external outbound connectivity. That's not a bad idea. So when you've got a dying phone, right? And what I mean by a dying phone is the phone isn't dying at all. The phone industry doesn't want you to hang on to the phone anymore. So they want you to buy the next one, because that's how they stay in business, by the way. Constant turnover. Android's the best of them, by the way. But the phone is still good. And you can connect this guy up to a local Wi-Fi, or you can actually utilize devices inputs on this to do certain things, specifically the camera, and so on. You see what I'm saying? Because, by the way, these cell phones have a type of magnetometer built into them. And cell phones have a really capable ability, if you were to put them on what's called a 360 rotation platform, and rotate it, it can spot every wireless node within the range of the cell phone. Can you say radar, people? That's what you got. The sky's the limit. But to allow the devices to be re-imaged and booted into this clustered environment means that you're putting these devices into a more functional capacity. Now, with that being said, when the cluster is built, how do you do the things you want to do? Like, I want to write a document, and so on and so on. Well, that's the beauty of it. You install the operating system into a resource pool. We call that a virtual machine. Not a virtual box, not a virtual service. Different. You create a virtual machine that has the operating system of your preference. Any of them is fine. The really cool thing about it is when it comes up, the plug and play analysis will say, hey, by the way, you need to know that this giant pool of resources is available to you. So every device out there that you have in your house is right there. And it just shows up in your Bluetooth or in your USB plug and play menu display screens. And you're like, well, let me pick what I want. See what I'm saying? So you created a general environment. And by the way, all of the equipment in your cluster can be powered off. That's fine. Power it off, power it on, whatever you want to do. All you need is one of the nodes to be operational. That's called a controller node. And there'll be two of the controller nodes. And it could be as simple as a couple of cell phones that are plugged up, and they use Wi-Fi for connectivity, and their operating systems have been reloaded to run the cluster set. We can call that my control nodes. And all it does is add and remove resources to the pool. That's its only job. And a standard ARMS processor can easily do that work without any issues whatsoever. So the options are really awesome. If you're in the scientific world, it's even broader. If you're in the HPC environments, it really does bring another value to the discussion, because with this cluster model, all processors, NTUs, FPUs, GPUs, all of them, SPUs, storage processor units, those are the controller sets that sit on your high-end cards. They all have value, and they are added to the equation. Just as cryptocurrency proved you can do it, that means this cluster environment can use it. That's pretty awesome, don't you think? I do. Now, the other thing about this, which is going to go a little farther out, right? If you really wanted to do something that had the ability to render, grouping GPUs, let's say you have 4 computers in the house that have decent video cards. Well, that's 4 video cards that can be put together to do a render and to generate an image which will sit on your final home, your local storage pool. And then you get the video, the MP4, and you play it, and you're rendering the equivalency of that of the open industry standards of today. It's the same way in dealing with AI and other kinds of services. For instance, you want to have a monologue AI in your house. It can talk to you, and you can talk back, and it can answer with some decent responses. Again, processors, GPUs, and so on, having them present in the cluster means they're available. Now, it won't be quite as fast as having a couple of GPUs in a single tower with a single processor stack and so on. It will be slightly slower, but it will be faster than an Intel processor doing the work all by itself. So that's value, something to think about. And all in all, as you begin to play and experiment with your fiber optic pyramid structure, in other words, your fastest to your slowest, you'll learn to upgrade certain nodes, specifically the ones with GPUs, up to the 10 gigabit pathways so that they can respond more effectively like they would have been in a single server rack, like they're trying to do today. Now, all the heavy-hitting environments don't do that at all. They actually do something very similar to what I'm talking about now, except they don't care about anything else. They don't want MPUs, they don't want NTUs, they don't want any of that stuff. They want just processors. Very limited thinking, in my opinion. We can do better, because this is absolutely the type of cluster OS environment I would want on a boat, let's say a cruise ship, or a spaceship or a naval vessel or an airplane, where all the devices coincide with each other in a uniform, heavily encrypted environment that allows them to act as one, and all their little tiny pieces they can contribute become your master pool of resources going forward. Now, this takes a little bit of ingenuity in the thought process to break it all out, but I got great news for everybody. It already exists. We just don't realize it. That's the secret sauce to this equation. It's already all out there. It's just broken down in different operating systems. And finally, I can say from the days of Beowulf clustering, we are cross-platforming operating systems heavily these days. And for good reason, because we can. Which means all the primary code we need to be able to cross-platform operating systems, it's all present today. May it be using Photon for integration to do computer gaming and so on, you can still do all of that. It's just better integration, that's all. I would say this new cluster operating environment is really just bringing all the players into one form. Question out to all of you IT guys and gals who have worked with Linux kernels and so on and so on. Here are your big challenges. One, it has to be agnostic from difficulty setup. In other words, when you build your first node, it's going to give you an ISO image saying, deploy this ISO image on everything else, just this one ISO image. And you do that, and you take that ISO, and you deploy it, and you really don't interact with it. It boots up off the stick, it goes and finds the primary, gives its own distinctual value. In other words, it will give a numerical position within the cluster, and it's done. Then you go to the next one, and you go to the next one, and you go to the next one, and you go to the next one, until all of them are done. And of course, if you have to have a special version of the ISO, it can do that for ARMS processors. But if you do it right, it should one ISO can do them all. That's the beauty. Because if it's an x86 based platform, with the x86 support, co-support platforms that work on that, this should be done. All the drivers have been written. Everything is out there. The image might be a little fat, but not really. The key thing is understanding that nobody interacts with the devices directly. They indirectly work with them on basically a GUI interface. In other words, once you've put a device on, you bring the device up, you allow the device's visibility or functionality or whatever component you want to use on it, or if you want to actually interact with it, you can. It's all graphical user interface because it's just basically saying, what would you like to do? And you say, I need an operating system. What type? Windows. Okay, not a problem. Do you have a license key? Yes, I do. Boom. You got yourself a Windows system. And it's sitting out there and it's using resources from your cluster. And you can play games, you can do all the things you want to do, all side by side, as well as saying, okay, now I want to do a Microsoft Word document. And you're doing the document, right? You're doing it, you're doing it, you're doing it. And then you say, okay, I'm done. I want to print it. This doesn't have a printer. And internet printing is not great, but you do have a local pool of 4 printers within the cluster. Which one would you like to print to? Pick one, done. Oh, I need to scan an image. Cell phone. So I say, what's my scanner availability? I see the 3D picture. I'm sorry, the 3D scanner. I put the object on the scanner. I hit a scan. Comes out here as a DL file. Sorry. Or some type of AutoCAD or DrawCAD or PrintCAD format that comes out. But this little guy did everything using the cluster. Now, for the industry, that's the PC industry, by the way, this is good and this is bad. It can redefine the market for PCs and broaden the scale of computer systems tremendously. The bad part is, how can they become the controlling interest in the market as this spins up? Good question, don't you think? They don't have to do anything, technically. They already make the hardware the way we need it. So all you have to do is use what you've got. And it's backward compatible to 15 years. So that's pretty cool too. Just think, you can use an EMT64 based processor, which is no longer a usable processor in any other environment. But in this environment, you could. Something to think about. Anyways, with that being said, this is Brad Dyke. This is a continuation, call it part 2, of the, hey guys, we need a new cluster OS that's smarter, better, and more effectual to what we can really do with our computers if we put our minds to it. Keep reinventing, keep taking the stuff out of the trash cans and turning them on, making them work, figuring out how to use them in a different way. That's just making you smarter, more capable. Learn. That's why I do all of this work here, is to let you learn, to share my knowledge with you, ideas and thoughts, so that you can take that knowledge and with good moral and ethical application, because the good Lord says do things for good reasons, go for it. This is Brad Dyke signing off. God bless. I hope you guys have a great week, and you guys take care. Bye-bye.